Um, so first of all, welcome to everyone to the first BCS USA webinar. So great work from Darren O'Sullivan and John Jeffrey, who are here. So first of all, thank you very much for everyone for joining. And I would like to thank the speakers as well. So let me go through, I won't be speaking very long. I'm just a couple of points to explain who we are, what we're doing. So my name is Nadia Boyub. I'm actually a member of the BCS AI specialist group. And the interesting topics of this webinar will be focused on AI and the 5 stories around AI. And one of the key elements, obviously, the BCS being the British Computer Society, it's a perfect platform for you to be connecting with local groups. So, for example, in the UK, we have groups by different region and the specialist groups. So we have the quantum, we have security group, we have the AI specialist groups, many different group as well, even related to industry, for example, medical or business analyst. And you can see all of that into the British Computer Society's website. If you're not a member, I'm sure that Darren and John will cover that. We have a slide at the end. A couple of housekeeping rules. We are going to be starting, we have 5 great stories that are going to be told. It's called 5 stories around AI. Each of the speakers will have 12 minutes. We will have question at the end. We will start with Dr. Biswan Senapati, then after Dr. Ilya Kolochenko, Sindanta Panigrahi, Sanjan Kand, and Donata Strong Skirro. So I will stop sharing my slide in order that Dr. Biswan can share his. Oops. Here we go.
Yeah, so thank you, Nadia. So you can share my slides, or do I need to share my slide?
Yes, if you can share your slide.
Oh, okay. So that's a big, okay, that's fine. Let me do that. Thank you, guys. Yeah, give me a minute because my laptop doesn't have it's the camera is not working, so I'm joining phone for the camera, and then yeah, 1 second. Give me a minute. That's all. Okay. So good afternoon, guys. Good afternoon, good morning, good evening, whichever time zone you are.
Otherwise,
Um.
send
Yeah.
them to me and I can share them for you.
Okay. No problem. I'm sharing here. No issue. I'm sharing my screen. Okay. Um.
Um,
Can you guys see my screen?
Not yet.
Okay. Can you? It says host disable the participant screen sharing. Can you please enable me?
Yeah, John, would you mind to? Would that be possible to enable this one?
Oh yeah.
Thank you. All right. So today we would like to see the quantum computing. Okay. So I think you guys must aware of quantum computers, or you must heard about the quantum computing, right? So quantum computing is. You guys can see my screen, or it is something.
Yes.
Okay.
Yes.
Thank you. Let me put into presentation mode. Okay. So this is the thing I would like to talk for next 12 minutes. Myself, Dr. Bishwan. So I'm based out of
Now we can.
Chicago. Yeah, I'm based out of Chicago, Illinois. I'm a fellow BCS and fellow of a few more computing society. Today, I would like to present what are the things we can discuss in quantum computing and how quantum computing is getting created, how can we access the quantum computers, what are the key constraint or key functionality in quantum computing, and what are the key language you can use in quantum computing, and also what are the key innovation that is applicable in quantum AI or quantum machine learning. Okay. So you can see the quantum computers, it's similar to the classic computer we are using. So if you look at the classic computer we have currently, like laptop, desktop, or palm top, whichever we are using, it start with 0 and 1, right? We are sending information, and computer is processing in the computing processing units, and then the processing unit will give the output. So we are giving a information, data will be processed, and then we are getting output. The same way quantum computer works, but quantum computer is working in little different than the bit, like classic bits. We call 0 and 1. So it is working on like qubits, we call quantum information processing units, that is called qubits, which is nothing but 0 and 1. So typically, if you look at this, this slide, so you can see this is a bullet sphere, which is talk about nothing but your, where is my, yeah. So this is the bullet sphere. You can see this is nothing but your, the information or the 0 and 1 are getting entangled or it is paired with. So in the classic computer, the difference is your 0 and 1, basically 0 is nothing but no and 1 is nothing but yes. So that is at a given point of time, you can only see yes or no. But in quantum computer, you can see both are entangled in such a way the quantum properties are enabled or inbuilt, and then you can see 0 and 1 are in the same place. So that is called the quantum property called entanglement. So we'll go there. So if you look at why quantum computers are required or what is necessity of quantum computers. So the quantum computers is the machine that perform the functionality of quantum mechanics. If you look at any computer, so this is under the mechanics, right? The quantum physics, quantum mechanics, quantum chemistry, quantum material science, or quantum computation science. There are many things in called quantum. Similarly, in classic computer, we see the classic computer also build on the physical properties, right? Zero, one, atom, proton, electron, neutron. So these are we already studied in the past, right? So similarly in quantum, the beauty of quantum computers is based on the quantum mechanics, because the quantum mechanics is nothing but your behavior of particle that is available in the subatomic level. For example, your electrons, your protons, your neutrons, your zero and ones means you have information which is zero, one. We have no information which is zero. That's nothing but your quantum properties, right? So basically, quantum mechanics is but nothing but it's a wave particle that also align to your the basically the how you wanted to process the information. For example, I have a trillion data records. I want to process through quantum computer to get the result in faster. How do I do that? So if my computer is a classic computer, it may take a couple of years or a couple of days or a couple of months to process, right? Let's understand a little bit about the quantum mechanics and where it started, right? If you look at the quantum mechanics, it is started in 1980 and now we are in 2025. So a lot of company, they have processed the quantum computers like Google, Microsoft, or any of the company you can see, they have the quantum computers, quantum machines. Now we are capable enough to create 500 qubits quantum computers at our place, right? So if you look at the quantum computing history, the quantum mechanics history, it started in 1980. Then we did a lot of research in 1985. Since then, in 1994, Peter Search have elaborated a lot of quantum algorithm, we call Search algorithm. And then 1998, the first quantum error correction was determined. We can say the why quantum error correction is required, or what are the things we can do to correct the quantum error correction, right? And then the first quantum computing available to us is, let's say, I would say the couple of years before, right? Now it is not publicly available. You can't create that. You can't you can't operate that quantum computers. But there are some simulator available where you can train the models. You can use your quantum AI if it is your AI application. If you're using machine learning application, you can do that. If you're using deep learning application, you can do that. So that is called quantum simulators. But quantum computers are available to use and to see the substantial benefits. So let's see what are the key differences or what are the key data like in a processing in the quantum versus classical computer. For example, in classic computing, we see this is 0 and 1, that is called bit, right? Information is getting passes through computer processor through 0 and 1. Similarly, in quantum computers, we have the sending the same information 0 and 1. So that is called qubits. If you look at the classic computer, this is called classic bit versus a quantum computer, which has a process like, qubits. So that's nothing but your, basically both the 0 and 1 stands in the same time. For example, the your 0 and 1, the both axes, like it is spinning the same way, the similar features, your processing power of computer will be much faster. And you can see the computers are operating not a normal, processing speed. It will be very, very superficial speed, right? That's the reason it's called your, the quantum computing, or quantum computing are processed through quantum processing units typically. Okay, so you may ask, like, how many how many qubits we can use. So is there a limit? There is no limit, basically. So we can create a quantum computers based on our quantum gates. Basically, we need to create a harmonic gates. We have to prepare those logic, programming, and then you can maintain like quantum single bit. Let's say 0 and 1. That is called single bit, a one digit. If you wanted to make a two-digit quantum computer, the zero like 00 state, or 01 state, or 10 or 11 state, you can make that to the power 2, right? So in 3 qubits, you can make like 8 states, like 000, 010, 001, and 100, 101, 110, and 111. So this is called the power of quantum computer would be to the power n. So n is nothing but your qubits bits, right? Similarly, you can make that. It's not a impossible thing to do, right? So let's talk about what are the key property a quantum computer generally have, right? We can see in the logical as well as physical state. A quantum computers has like some of the key properties. One is the superpositions, and second one is entanglement. Third one is interference. So basically, quantum computing, like superposition, nothing but, let's say, as I told you, a quantum computer will process the same information like 0 and 1 qubits. So the qubits are like available in the same state. You will see 0 and you also see 1. So you may surprise why how the 0 and 1s are same state, right? Because the quantum computer is made in such a way, so you can see the power of computers is so superficial, and the 0 and 1 would be available in the same space. It's not like that 0 is nothing but no, 1 is for yes. No, it's not like that. You will see the superposition in such a way the all the qubits are available in the same state, right? That is called superpositions. And in entanglement, so no matter what distance you are, no matter what operation you are doing, so two or more qubits become entangled. That means they share the strong and their information, they correlated, and they, regardless of their distance or the time or the processing, right? That is called your entanglement. So it's very, very essential when you create or when you make a quantum computers, you have to look a couple of things. One is the quantum computers should have a superposition properties, they should have entanglement, they should have interference, and they should have zero or least decoherence. So I would tell you what is decoherence. So quantum computers are highly sensitive to the nature, like environments. So if something, a noise, we can call noise correction, right? So if something in a given state, your quantum computers we are processing or we are utilizing, that may comes to a state where the properties, quantum properties are not there. That means the 0 and 1 are not available at a single spot. So that is called decoherence properties, which means it has impacted with like external factor like environment, temperature, your like logical things, and then this property of quantum computer will be no longer available. That is called classic computers. So that means we can build a computer which has a classic properties as well as quantum properties, right? So we'll talk about later. That's called decoherence properties. So generally, in scientists in quantum computers, we do not need our computers should be in decoherence mode. So we always call coherence. That means the quantum properties are available across the time. Okay. So typically, you may have a question like, what are the mathematical formula, or what are the mathematics, or the physics, or the chemistry allies to quantum computers? Yes, quantum computing is based on some of the quantum mathematical algorithm. So most of the quantum mathematical algorithm are falling under this, like Gauss's algorithm, which is very, very essential and critical to have a factorization of number, right? And then Peter Sir, I told you like Peter Sir is established a quantum company in 1984. So the source algorithm is very, very useful. The fast numbering factorization and quantum unconstrained binary optimization, that's very essential for QKD, like quantum cryptography. And then Hamiltonian equation, that's very essential So all these like quantum algorithms are essential to perform a quantum computing properties. For example, you may have a
Just one, sorry. You've got, like, we had to wrap up. You have 20
okay.
seconds. So, yeah,
All
thank you.
right, sure. You're welcome. And then, okay, how do you execute a quantum computers in real time? You can execute the quantum computer through quantum simulator, or if you have a lab where you can access the quantum physical computing, you can do that. So typically you can do Qiskit, Civic, and then Bracket. This is from Amazon. And then recently Microsoft offer a quantum computer that is called Liquid. Okay. So what are the applications? So yes, there are numerous applications in quantum computing like quantum machine learning, quantum cryptography, quantum teleportation, quantum post cryptography, and also quantum internet. Okay, this thing you can done in quantum computing. So typically quantum cryptography is very essential. I have done numerous projects in quantum cryptography as well as quantum teleportations.
Hi,
You can,
sorry, we have to wrap up because it's 13 minutes.
okay,
So,
all
yeah,
right.
so, yeah, thank you.
I think you're welcome. So I think I'm good. So this is the post quantum cryptography we'll talk about later in the state because it has a lot of information where we need to talk in later. Thank you very much. And if you have any question or concern, please feel free to reach out to me or the BCS. Thank you.
Thank you so much. It was very interesting. I know there's so much insight on this one, but never mind. What we have the Q&A. So if there's not too many questions, each of you can add some elements there, so that like this everyone can hear about all of the presentation. So now the next one. So Dr. Elia, if you are Dr. Elia, if you're ready
Yes,
to share your presentation as well.
sure. I'll be happy to do this. Please just give me 1 second. Uh,
Okay, fantastic. Yeah.
awesome. Can you see my screen?
Yes, we can. We can
Excellent.
see your ice cream.
So
Your
today
screen.
we'll have probably the shortest introduction to practical implication of GenAI in cybersecurity and cybercrime. Okay. I have 12 slides, so we'll have 1 slide per minute. If you need a copy, just let me know. Okay. So let's talk about artificial intelligence in 2025. So basically speaking, as we'll see in a moment, machine learning and artificial intelligence are pretty old concepts. And actually, when we talk about AI today, we likely mean generative AI. And when we say generative AI, we'll likely refer to the transformers architecture of artificial neural networks, deep learning that was introduced in 2017 in a research paper by Google scholars. Okay, this is actually what really paved the way down towards what we have now with large language models such as Llama by Facebook or many other models that you may know. Okay. Let's very quickly go through the history of machine learning and AI. So no, this is not a typo. I frequently have this question, 1906. That's correct. Of course, it was a prototype on paper. Okay, so we didn't have computers back in 1906. Okay, but this is when the first prototype of machine learning and very basic form of generative AI was created. We had a sort of, chatbot, very basic one, but with keyboard and screen back in 1964, okay, at the MIT. So ChatGPT is far from being the pioneer, okay. This is the paper I just mentioned. This is actually what created the possibility to build all this awesome LLMs that we all use for the different purposes. Okay. The only important thing to mention that GenAI has nothing to do with human way of reasoning or generating text and answers. Okay. Unfortunately, we don't have enough time, but just bear in mind that the way how our brain functions has nothing to do with GenAI and large language models. Also, we have a lot of very important questions about ethics and potential misuse or discrimination by AI. But I've been always saying that AI is just a technology, so it cannot and it does not discriminate by design, but for training data or a discriminating data set may and probably inevitably will discriminate. Okay, so it's not about technology, it's about the training data. Okay? Just before you get disappointed and start thinking that I'm an jaded AI guy who is extremely pessimistic about AI, AI certainly has and will have a lot of great areas where it can intelligently automate many different tasks and processes. And at my own cyber security company, we've been using machine learning and AI for intelligent automation and acceleration of different cyber security tasks and processes since 2017. So far before the public launch of ChatGPT in November 2022. So yeah, there are certain tasks that AI can and actually does much better and faster compared to human beings. Okay, does it mean that it will replace us? Unlikely. Okay. So let's briefly talk about cybersecurity. This beautiful infographics comes from Gartner, and here you can see a plethora of different tasks and processes where AI is currently being used by cybersecurity professionals. I've been in cybersecurity for almost 2 decades. That's another way to say that I'm an old man. Generally speaking, we certainly see some benefits, for example, very basic thing, anti-spam becomes a little bit better, okay? Web application firewalls may better detect uncommon attack patterns, you name it. But there is no revolution. We still need well-educated and experienced software engineers, cybersecurity analysts, and many other people. Yes, they will be augmented and they will be able to spend more time on complex tasks that truly deserve human intelligence, okay? But they will certainly not replace human beings, okay? So just, couple of thoughts about, the risks for AI, and you can see here a report from the Cloud Security Alliance about, concerns that cybersecurity professionals have relating to GenAI. And I think this is something that currently hinders wider adoption of GenAI in different areas, including cybersecurity. Okay. Regulating AI, I'm confident most of you have heard of EU AI Act. In my humble opinion, and in my personal opinion, this act is far too lenient, but it's better than nothing because, for example, in the US, we still have no federal law on AI. So many states are currently trying to legislate, and it will be a big challenge to comply with everything. Okay. Best practices for cybersecurity of your own AI models or fine-tuned models that you have very quickly here. Nothing substantially new, nothing, unseen. Basically speaking, we follow the same principles and implementing, I would say, similar security controls as we do with all other types of technologies that we have. Okay. Cybercrime. So this is a very interesting slide, from the National Cybersecurity Center. So as you can see, basically speaking, AI created a lot of opportunities for fraudsters and scammers, but not for cybercrime gangs. I mean, for professional cyber criminals, because they can and they actually do write malware better and faster. when we talk about, primitive malware or primitive exploits or primitive, vulnerabilities that are being detected by AI, yes, this can, and it is actually being automated by AI. But professional APT groups, advanced persistent threats, they don't need it because all code by AI is far too primitive for their needs. Okay, and also we had countless automated tools, nothing in common with AI for automated vulnerability detection, exploit, curation, payload fine-tuning. So basically speaking, AI produced many opportunities, but not for advanced cyber criminals. Okay. The FBI also says that we have computer-enabled crime. So this is all like, scam you may spot on Facebook, vishing, smishing, different type of things. And yes, AI is extremely powerful. And yes, AI is currently being exploited to bypass even biometrical authentication, deepfakes. That's a big problem. Okay. But AI will not start finding zero-day vulnerabilities, hacking unhackable systems. This will not happen at least for the next 5-10 years. Okay. All right, future of AI. My brief thoughts. So we'll probably see a lot of competition in all countries, I'd say. The biggest problem probably will be, lack of high quality and current, up-to-date data for training. And also the regulatory landscape will likely be extremely complex and intertwined with other laws and regulations. So selling AI will be expensive, and maybe a lot of current market leaders will start losing money. Okay. Last slide, being respectful of everyone's time. So I believe that we have slight disappointment of investors, but no drama. Okay. We'll probably see a lot of niche areas where AI will truly produce amazing results, outperforming human experts. This will come. Complex regulatory landscape. And also we'll see that AI will become more reliable, but only in relation to specific tasks and processes. And AI will be awesome. For example, will be able to do many things faster and better, but it will it doesn't mean that AI will replace us. Okay, so we'll have a good progress, but I think human intelligence, human capacity to reason and to make decisions and to create, to innovate will still remain extremely valuable. So thank you so much for having me here today. If you have any questions or comments, please feel free to reach out. I'm here to help. Thank you so much.
Thank you so much, Ilya. So now we can pass on to Siddhanta. And then
Thank you.
obviously, if you have any question for Dr. Ilya Kolochenko, we can cover that at the end.
Yeah.
It's all yours, Siddhanta.
Yeah. Thank you.
Perfect. We can see your slides. So we can see them now. Fantastic.
Great. Thank you very much. Yeah, I know we hear a lot story about quantum computing and AI in cybersecurity. Let's talk about something different in AI. Okay. Good evening, good morning, or good afternoon, based on the time zone. And I'm Siddhanta Panigrahi, and I'm working in Okta at the same time. I'm engaged in doing my MBA in Haas School of Business in UC Berkeley. Today we'll talk about how AI can change the world of logistics. Let's start it. Let's begin by looking some of the core pain point in the traditional, logistic, like what we have. Like we have today all inefficient route planning, delay in delivery. It's for all, like truck or broker, warehouse management. And there is no way we have a different system altogether integrated, but there is no knowledge into that for adding any kind of prediction or rerouting or remanaging your inventory. In the e-commerce boom of today's, we need an efficient routing and delivery process and processing within the inventory, and which lead to a cost effective, and also due to the labor shortage in the global developing world, which we need an efficient process to deal with it. So coming into the these all different area of the logistic, we do see a lot of problem. So how do you solve it, or what are the different use cases we can think about, and different company and startups are working on it. Um, so let's talk about some of the case study in Excel to be. Um, think about an AI integrated fleet and delivery management. So today in US alone, the total logistic of truckers itself is close to 1 trillion USD, which is around 890 billion. 40% of those trucks running in US today are going vacant. They are just running vacant, empty truck. 20 to 30% of them are running half capacity. So think about bringing an AI integration fleet, which could help them the truckers running full, which could reduce your carbon footprint, which could give the profitability to everyone. And think about a static delivery and planning kind of management. Like today, I know something shipped to me, there is a route, kind of hub and spoke model. My packages got delivered, it'll come through X, Y, G, and to me, but there is no dynamic way of doing it. But AI can help on those things as well. The routing, planning, demand planning, including your warehouse management, right? Um, if you get your truck full capacity, if you think about rerouting your all the logistic, if you think about a efficient delivery management, then that will be help us reducing 20% of the time and so cost. So it will also help to reduce our carbon footprint, which will directly impacting your greenhouse emissions. So how does it work altogether, right? So there are like different way. There are like you have a different data sources. We have a IoT, we have a different sensor, we have a GPS, we have a AI ML model, and we have a different ERP system for different like warehouse, inventory, everywhere, and then we can integrate this all together, and we can use an AI technique and machine learning and NLP and computer vision to make this thing efficient. And this will even help us to get better forecasting and anomaly detection and process automation. These are not just a technical things to be done, but these are actually the real world application, which is started by some of the company like Uber and Amazon Fleet, but not yet in a full driven AI kind of logistic company. So it is still evolving in nature. So we can expect this to be next 5 to 10 year, a full capacity AI. I know some of the warehouse they deployed robot, and they work on the cycle count, they worked on their inventory, the kind of logistic here and there, but a total end-to-end is not yet there. Starting from your home to the trucker to the shipping company to the logistics. So that whole is not yet there. So I'm pretty sure the way the AI is evolving day by day, we can see this, and I know there are some companies started. There are some startups also coming up with this. So it's great story coming up it. So what benefit we can get it when we talk about all those things, right? So there are a lot of tangible benefit to the organization with AI. Start Starting from the improving operational efficiency and real time tracking to demand forecasting and dynamic pricing. AI adds measurable values. It enhance your customer satisfaction, reduce error, reduce cost, and then improve benefit to the companies and people end of the day, and support green initiative through smarter routing. All of this lead to agile, scalable, and sustainable logistic model. But as usual, I know my previous speaker talked about ethical consideration of AI and on the cyber security. Similarly, we do have a big problem today about ethics in AI, right? And how to overcome it, right? There are some definitely a tangible benefit. We are seeing it, but despite those benefits, there are a lot of challenges in AI adoption, and how you think about your data privacy, cyber security, then algorithm bias, right? Who wrote that algorithm today, right? If you There are a lot of algorithm, including LLM, in the market available where you type about a race and gender, you could see there is a difference how they respond to you, right? So how to address those things? These are not now just a technical issues we need to work on, but there are a lot of ethical and strategic issues we have to be addressed. We must also negate the regular complexities such as cost, because looking into cost, we just think about let's build a model which is profitable for us on this AI for logistic, and which can help us on starting from your planning to logistic to warehouse management to robotics. But we need to also think about ethical consideration. So that is the key for us, right? Um, this this is definitely a fear, and for everyone. And I know there are big companies are working on it, but not everyone. So addressing this proactively is crucial for success of AI. So end of the day, we have to be concerned on this to get success into our AI. Sorry. the, the future of kind of logistic, like how does it be looking like, right? So we could see a autonomous truck which is coming up. I know there are companies working on it. Drone delivery, which is started. We could see more and more. There are robotics machines delivering your home door, which I could see in my area in California, like East Bay. Like I could see the robots are roaming around. There is a testing going on, so you could see more and more cities getting adopted across the world, and we could see AI and blockchain for transparent and supply. So blockchain can be used as a unique token for any truck or driver kind of the moment, and self-healing supply chain, intelligent robotic, and logistic powered by AI, and end of the day the predicative and dynamic pricing. So everything can be a part and parcel of the logistic in AI, come as a bundle. I'm pretty sure we are not there, but this is what the future for us. And I'm working on this as well with some startups, which is in the stealth mode. Uh, I don't want to take much time. I know we're in time. Um, End of the day, as I said, to conclude my topic, AI is definitely no longer a future thing. It's a present thing, which everyone is working. And I know AI with quantum computing is going to be a game changer. What one of my speaker talked about it, and the strategic in AI will help us on efficiency. It'll help us on quicker, adaptable, and customer satisfaction. So the time will tell. Everything will be AI in one day for sure. That's about my topic today. I'll say thank you very much. Anything you can talk to BCS or myself.
Thank you so much, Siddhanta. Brilliant, perfect timing. Thank you. I'm aware that you have to go, so exceptionally, if anyone had any question for Siddhanta, please can you let us know? Type it on the chat, because I know that you have to go. So for the moment, there's no question. In any case, if there are any after, we can we can forward them to you. Okay.
Yeah,
So
route to me, and
far,
then I'll happy to answer on this thing.
okay, fantastic. Thank you so much. Yeah, so now it's the turn for Sanjay Kant to. Is that possible for you to share your presentation?
Yeah, 1 second, let me do it.
So I'm checking the chat. There's still no question for you, but I'll keep an eye on it.
Thank
Are you
you.
able to see my screen?
Yes, we can. We can. Yes.
Hi, my name.
Securing AI to combat fake news, right?
Yeah. Hi, my name is
Fantastic.
Sanjay Kant Somanathan Pillai. I'm a researcher at the University of North Dakota, and I work for Visa as well. Today's topic is about Truth Shield, securing AI to combat fake news. On this discussion, we will talk about what is an information, what are the impacts of misinformation, what are the characteristics of misinformation, and we will talk about finding and removing some, fake news super spreaders, and what are the impacts of sentimental analysis in improving the accuracy of machine learning models. So what are the information? What is an information? The definition for information is a piece of data that if we processed or organized, it will convey some meanings to it or reduce the confusion. What are the different types of information available there? There are 5 types of information available. One is true, fake or false, misinformation, disinformation, and neutral. What is a true information? Which means that it is true unquestionably. What is a false information? A true information, an example for a true information is, say, for example, today is Friday. That's a true information. There is no confusion about it. A fake information is that unquestionably it is incorrect. If I say today is Monday, it's a false information. And the third type of information is a misinformation, which is a false or out of context information that is intentionally or unintentionally presented as a fact to deceive, is a form of misinformation. So the person who's saying something, say for example, they say something, they may think that it is true, but at the same time it is not. So they are not intentionally saying that, to deceive the people. So this kind of information is called a misinformation. And the fourth type of information is a disinformation. It's a type of misinformation, but the only difference between a misinformation and disinformation is that the person tries to deceive or mislead, readers intentionally. The keyword intentional is the main difference between misinformation and disinformation. An example of disinformation is that, COVID vaccine injects some chips into your body. If you take a COVID-19 vaccine, that is a disinformation. The neutral information is nothing but we cannot verify the accuracy of the statement by the current method. Say, for example, COVID-19 virus was produced in a lab in Wuhan, China. We don't know whether it is right or not. So that is a neutral information. These are different types of informations, and the difference between an information and message is that a message is a piece of data that we use to transfer communication between two entities. It can be sender receiver, senders, receiver like that. Now let's talk about what are the impacts of healthcare misinformation. I choose the topic as a healthcare because we have seen what happened during the COVID-19 pandemic. And I'm going to talk about, 4 impacts of healthcare misinformation. According to World Health Organization and US Department of Health and Human Service, on a social media platform, a fake information can travel 70% more. It gets shared 70% more than a true news. A brief exposure to COVID-19 vaccine misinformation made people less likely to want a COVID-19 vaccine, which means that, say, for example, people think that you inject COVID-19 vaccine and they put a chip on your body and they can track you. The government can track you. That's a misinformation. So people doesn't want to take the COVID-19 vaccine because of this. This is an impact of healthcare misinformation. Misinformation has also led to the harassment and violence against public health workers, healthcare professionals, airline staff, and other frontline workers. I'll tell you an example. During COVID-19, a lot of people were infected with the COVID-19 virus. So they wanted to get the treatment as early as possible, and they go to the healthcare systems and say, "Hey, why don't you give me a treatment?" And they may say that, "Hey, we are full, and we can only give you some medicine, and you have to go home and treat it by yourself, or take the remedy by yourself." They make it angry, and attack. They may attack even the healthcare professionals. And it is the same happen with the airline staff and other frontline workers as well. I was just talking about one of the examples. There are a ton of other examples that, if time permits, we could easily articulate. And another healthcare misinformation impact is that World Health Organization has led to the removal of 850,000 YouTube videos related to harmful and misleading COVID-19 misinformation. Remember, it's only for COVID-19 misinformation. And World Health Organization has to remove 850,000 YouTube videos between February 2020 and 2021 Jan, which is within a span of 11 months, they had to remove 850,000 videos. So this is another impacts of healthcare misinformation. Now we will talk about the characteristics of fake news. Fake news and misinformation, how they propagate from one person to another person. The first chart, it talks about the receiver post time delay, top right corner. It says that how fast, when someone receives the fake news, how fast they retweet it or repost it in online social media. You can see that false news, even though it takes longer time to repost it, they still do. But in case of true news, they instantly, or shorter period of time, they repost it, and that's it. That's done. If you talk about the receiver post time delay on the right side, on the red dot plot is a false news. You can see that it stays there in the atmosphere or in the social media for quite period of time. On the bottom left corner, you can see a chart where it says the participant count, where you can see that clearly. An orange one indicates that the false news, and the blue one is for true news. You can clearly see that from the chart that for the true news, the lot of people participated initially, but in terms of fake news, it slowly retweeted it. Actually, people started retweeting very slowly, and it stays there for over a period of time compared to the true news. Now we'll take a look at the top bottom right chart. It says us how far a fake news and a true news can travel. It is called the propagation speed or propagation length. If you look at the right side for fake news, you can see that a fake news does travel more distance than a real news. The summary of the fake news is that the fake news, even though people doesn't retweet it as fast as the true news, but it still stays there in the atmosphere or in the social media for quite a long time. And more number of people, they retweet it again and again and again, even after, say, for example, 1 month, 2 months, 3 months, 1 year, people still retweet the same. So let's talk about, people who are retweeting the tweets. A super spreader is someone who retweet more number of fake news or a false news. The bubble plot on the left side that you see, that in the Twitter 15 data set, you can see a lot of bubble plot. And each bubble plot describes the number of people who are there in the network. They shared the news between each others. So the smaller bubble means the lesser number of people involved in tweeting with each other or sharing with each other. So the idea was to find out one super spreader, and let's see if we can, by removing that particular super spreader, can we break their chain so that, they will be, there won't be much fake news spread in between them. So which means that if we remove one person, see whether we can break their chain so that there won't be much, venue for them to share their fake news, which means that they will stop at the stage. By removing one super spreader, you see that, we were able to break the chain and they were spread in between. The bubble plot is only about the fake news, and I'm not talking about, or I'm not involving a true news or other type of news. When removing one false news, you can see that, we were able to break their system or break their channel so that, the social Twitter or any other social media will be, less number of chance to propagate this fake news within their systems. And what are the different impacts of sentimental and emotional classifiers in improving the accuracy of a social media? So sentimental analysis is nothing but, we can say that a negative, a neutral, or a positive cases as a sentimental classifier. And in emotional classifiers is if you classify a sentence as an anger, love, joy, sadness, surprise, fear, like that you classify. So how we can use this sentimental and emotional classifier, and can we use it to improve the accuracy of a machine learning model that you use without a sentimental, that we are doing without a sentimental analysis? Here you can see that when you are adding a sentimental classifier to the input of the news, that you can see that the accuracy is improving beyond a certain limit than the previous one without using a sentimental classifier. This is the best way to use a sentimental classifier and emotional classifier to improve the accuracy as well. That's it.
Oh, okay, great. Right, okay. Thank you.
Right on time.
Perfect timing. Thank you so much. As for the other speakers, if you have any questions for Second Cantos, we can go through the questions after the last presentation from Donata Strings-Kilrood. Hi, Donata.
Hi,
Okay,
thank you so much.
Yeah,
can you see my screen okay?
Yes.
Awesome,
Yes,
thank you. So I'm Donata Strings-Kilrood, and I'll be talking about building responsible AI, including the legal and the regulatory requirements. Now, because I'm an attorney, I did want to note that I'm not providing legal advice. This is just for informational purposes only. So why are we regulating AI? If you're a builder, you might not want regulations, right? Because regulations can make it more difficult to build or disseminate your products. But there are certain key risks that are associated with AI. So just like the previous speaker spoke about disinformation, misinformation, and deepfakes, they increase the risks of government surveillance. There's a lot of issues with data privacy. There's issues with bias and discrimination. There can even be autonomous weapons that are not controlled by a human. It can be used to manipulate financial markets, manipulate elections and other democratic processes. It can also be used for criminal activity, like Ilya discussed, and then it can also lead to a loss of critical thinking and intellectual property too. Now, all of these things, they seem very nebulous when you say it like that. But I did want to note there are a couple interesting news articles about AI having very significant risks and issues. So, for example, somebody in Norway used ChatGPT to look up this individual, and ChatGPT said that he killed his sons, and that actually wasn't true. There's a company that used AI to process applications, and it automatically rejected all female applicants under the ages of 55 or older, meaning that it led to discrimination, with somebody actually losing the ability to gain employment. AI can lead to wrongful arrests. Like in Lee County, there was a man that was wrongfully arrested. There's been many news cases of attorneys using ChatGPT to write briefs, citing fake cases, which is not just an issue for their clients, because it can mean that their clients could potentially lose their case, but it's also an issue for an attorney who could be disciplined or could even lose their license. And probably worst of all, there's a lawsuit stating that an AI chatbot pushed a teen to commit suicide. So when it comes to building an AI, obviously as people, we don't want to be providing products or creating products that lead to these negative consequences for people. But also from a commercial standpoint, if your product has these types of issues or these types of outcomes, your product can be banned in particular countries. You can also be fined or sued for these negative outcomes. So if you want to build an AI that is able to be disseminated, able to be used, and have positive outcomes, you definitely should embrace regulation. So the Organization for Economic Cooperation and Development, OECD, has created AI principles. So 5 principles that have 47 adherents, including the European Union and the United States. So a lot of the legislation that is coming out is based on these principles. So these talk about inclusive growth, sustainable development, and well-being. Transparency and responsible disclosure, which includes documentation provided to users of the tool, documentation provided to other developers, things like that. Respecting the rule of law, human rights, democratic and human-centered values, including non-discrimination, privacy, and truth in information, meaning that we're trying to avoid disinformation and misinformation. We're trying to protect our privacy. We're making sure that autocratic governments are not misusing AI to surveil or punish people. We also want to make sure that there's security and safety. And lastly, accountability. So these principles say that the builders of the AI and the users of the AI are potentially responsible for any of these types of negative outcomes. Now, from these principles, we have a lot of different regulations that have come out all over the world. We have some regulations in the United States. Unfortunately, that's state by state, not federal. And we're also hearing that there might be a moratorium on AI legislation in the US. In the EU, we have the EU AI Act. We have a standard in Australia. We have different frameworks and different strategies and different bills being proposed for regulating AI. But most of them are built or based upon these AI principles that the OECD has agreed upon. So what I did here is we obviously don't have the time to go through every single standard and every single law and all of its variations. So I kind of pulled these requirements together to come up with a framework that you could potentially use. So the first step in developing an AI that would meet these regulatory requirements is to assess the risk that the AI system may pose. So the risk assessments are very similar to the EU AI Act, almost the same. So we have prohibited AI, like social scoring. You can't do that. You can't assess the risk of an individual committing crimes of a particular person. You have high risk AI, which can affect critical infrastructure, access to employment, access to services, law enforcement, and other similar processes. And then you also have general purpose AI, which is a model that displays generality, can perform a wide variety of tasks, and then can be integrated into other systems. So the first thing that you should do is assess the risk of the AI that you're building. So identify how the AI systems may be used and what they're meant for. Identify the ways that the system could attract malicious and harmful or inappropriate uses. So for example, could it be used to influence elections? Could it be used to discriminate against individuals? Discuss the intended uses and actual uses of the AI with stakeholders. Anybody who works in software, including myself, knows that you could build the most perfect, beautiful, intuitive system, and then the moment you have one user, they will use it for the exact opposite purpose of what you actually intended it for. So test the system, talk about how people may use it, and then perform a risk analysis. The second step would be developing documentation. So you need to create this documentation, you need to maintain it, which means that you need to continuously update it, and you need to make it available. So have technical documentation, like what data sets was your AI trained on? How was it tested? Documentation to providers of AI systems who intend to integrate your AI into their systems. So discuss what your systems are capable of and what are its limitations. Talk about how you're going to comply with laws. So if you build an AI, you still need to comply with privacy laws and you still need to comply with copyright laws. So how will you comply with those? Create a summary about the content used for training the AI model. So what training information went into the AI to build it so that people can go back and understand why the AI is doing the things that it's doing. Document the fact that you're demonstrating compliance. So what did you do to comply with GDPR, for example? And then have a policy and procedure detailing your risk management process. Transparency is extremely important because people use the internet and they might be interacting with AI and they don't know that they're interacting with AI. You might have deepfakes or misinformation or fake videos that are being created by the AI and nobody can tell that it's actually made by the AI. So make sure that an individual using the AI system knows that they're interacting with an AI and not an actual human. Any audio, images, videos, or text need to be marked in a machine-readable format and detectable as artificially generated or manipulated. So if there's a video that's being made by AI, it needs to have a watermark that is machine-readable to allow people to identify the fact that this is AI, this is not actually true, or this is not actual people. And this can help combat deepfakes as well. And you need to provide this information in a clear and distinguishable manner at the latest at the first time of interaction or exposure. So let's say somebody is opening up your AI tool. You need to make sure that right then and there, very visible, very clear, it says this is an AI tool. You're not interacting with an actual person. You're interacting with an AI. The fourth step that you want to consider is establish accountability for the AI system. So publish an accountability process, governance, internal capability, regulatory compliance, who's actually responsible for what. So make sure that all your staff are familiar with their roles and responsibilities and the requirements of those roles and responsibilities, and make sure to train your staff appropriately too. Provide human oversight in the deployment and operation of the AI system, and a mechanism for people to obtain redress if they are harmed. So your AI should have a contact system where somebody can reach an actual person. So let's say I'm an employer and I want to use your AI and I have noticed that it's automatically rejecting people of a certain age or a certain gender or who have certain education or certain backgrounds or even certain names, right? I want to make sure that I can speak to a human and say, hey, I think your AI has a bias issue. You need to fix this. Because otherwise these issues are just going to be perpetuated further and further without anything actually changing. Then you want to think about controls and testing. So make sure that proper controls and testing is in place. So test AI systems, implement data governance measures, manage data quality and provenance, use a wide variety of tools, evaluate the model performance and monitor the system once it's deployed. It's not just, oh, I created this AI and I unleashed it into the market and now just whatever happens, happens. You do need to test it continuously to make sure that it's performing the way it's supposed to perform. Allow adverse impacts to be identified and reported. So again, have something where a user can say, hey, I don't think this is right. This needs to be corrected. And then make sure that you're employing appropriate cybersecurity measures to prevent and identify attacks too. So that's all I have here. But if you have any questions, definitely let me know. Thank you.
Thank you. Thank you so much, Donata. Yeah, so we've got a bit of time, and that's fantastic because now we can into the questions. So let me share the last slides so you can see them. Again, hang on a second. Can you see my screen? Is that okay? Okay, good. Yes, so so question and answer. Anyone has any question for the speakers? John, can we see any question in the chat, or Darren?
Yeah, so we've got a question just asking about what might be the reasons for a lack of federal regulation.
Interesting. Donata or
Yeah.
Sachanka, don't know if you have any thoughts.
I'd be happy to take this one. So in the United States, it's very similar to our privacy legislation process, which is the fact that, people have been trying to pass federal comprehensive privacy legislation for many years, and have unfortunately failed time and time again. And there's multiple reasons for this. So the first reason is the inability for the drafters to do the process properly. So, for example, in the European Union with GDPR, there's a consultation process of many years of making sure that every stakeholder is heard, making sure that civil society is involved, making sure that all the risks are adequately understood and reflected in the legislation, making sure that the legislation is as future-proof as it can be. Unfortunately, in the United States, we don't have such a process. So the way that laws are passed and proposed in the United States is some lawmaker gets excited about privacy. They have their, clerk write up some kind of a bill, and then they put this bill forward without really consulting many people, and then nobody's on board with the bill, and nobody passes it. You'll see this time and time again with certain privacy laws that, you'll read the bill, and usually there will be blanks in the bill where you'd have like a number of people's of data being collected with usually that'd be like 10,000 or 35,000 people, but they copied and pasted the bill from another state or another place without reading it and leave it with blanks. Things like that. There's also very common objections like private rights of action or being friendly to businesses or lobbying issues. Something very similar is happening with AI in the sense that, nobody's really taking the time to create a bill that would be bought in for many stakeholders. They're trying to tack on AI regulations into privacy laws, which doesn't necessarily make full sense either. So you end up with this mishmash of bills, none of which are supported by anyone except for their drafter, maybe a few other people. And because of the way that our legal system is set up, any attempts at regulating AI end up crossed off the moment somebody else becomes president. So, President Biden had an AI framework that he published to develop, and his administration did work on that. And then with the new administration, that was just the executive order was just denied. It was struck out, and we started again from zero. And now we're seeing, proposals to have a moratorium on any AI laws for a certain number of years. So that may prohibit certain states even from passing AI-related legislation. So all of that kind of adds up into no federal law regarding AI.
Great, thank you so much. Anyone else would like to add a point or?
I mean, I would like to add a point here. So even though we don't have a law or regulations with respect to federal government, for example, HIPAA or let's say GDPR, CCPA, but AI is not meant for to get something and without any ethical practice. So there are some ethical concerns. There are some regulatory activities going on. So I have been leading a team in IEEE. So we are connecting with the US government and to lead those responsible AI, consciousness AI, and ethical AI. So no matter what you do in AI, but we all should have responsible enough to adopt any of the models. So we are not here to create a model for our own pleasure or own benefits. So we have to look certain things which should not impact it to any public or people or any kind of like against the law. For example, HIPAA. So I am a data scientist for healthcare. I can't reveal the personal information or public information which is not allow me to do, right? So there are certain things that are available in the market. I think yes. So as you say rightly, the government is not intent to do that right now, but yes, of course, it is going to happen soon. If you look at quantum AI, as a quantum scientist, I always look at the same philosophy. No matter how best my quantum computers are, I cannot use for any kind of unethical activities. Thank you.
Thank you very much. Any other point? Right? Okay, so we could probably move on to the next question. How can we make AI more screen reader friendly? Question from Camelela. So with the people with visually impaired, so people who are visually impaired. Thank you for the clarification. Any thoughts, ideas, anyone? Maybe on the human and interaction aspect of development.
I thought it was quite interesting. Was it? I think was it John Ivy of Apple's working on like a sort of AI wearable thing at the moment, and I can imagine their developments looking at something which is moving away from sort of dependency on screens entirely. So you might start to see those different ways that people are using AI to be able to engage and communicate.
That's true. And then as well, I came across some startups actually who have been working on AI solutions for helping people who are visually impaired or who have lost the eyesight as well. So they've been different initiatives been working on that, and some of them actually was one of them the glasses was put in, the person could actually start moving because of the algorithm helping the recognizing their environment, so they have some indications through the sound as well. So it's a combination. So there are some solutions. There's any other point, Carmelilla, do you wanted to highlight, or was it just by curiosity you wanted to find out? Yeah, so this Vana did as well. Yes, they are AI-powered smart glasses. Are there to be
I think
and
there are a lot of
smartphone
tools,
well
there are a lot of
tonight.
tool and technologies coming towards to solve this problem. It's not only visual impaired. Look at I guess people who can't speak or who can't
Yes,
hear, right? So there are
yes,
some tools are coming in the market. So typically it's a like we call neuromorphic. Have you heard neuromorphic? We talk about the human brains, and also based on the human brain, let's say I'm active persons, I don't need to do any kind of system assisted program, but somebody is not an active person, he is a impaired, visual impaired or challenging person, so that thing can be solved. But it is $1 million question. So people, still researchers are going to do a lot of things. We will be getting there soon.
yes. Yeah, thank you so much. Yes, so there have been quite a few initiatives. That's a good point, Camelilla. Let me put something in, giving some examples, and then there's the IT Now, which is the magazine. We work usually with them, or we have the newsletter as well, the community. So we can. So John, if we can take that offline, and we will prepare some examples for that, for answering that question. Like these people will follow up on it, they can see what really. So Kamalela, there will be some information on the community. That's a really good question. I like it. And it does, that's what I like when I see AI making a difference in our society. So that's, as this one said, and I said there, and John mentioned, there are quite a few examples on that. Okay. Then the next one, Gurpreet mentioned, as a project delivery manager working in government with little technical knowledge, what are the best AI and cyber certification and accredited course would you recommend for a non-degree master to understand more about AI and cybersecurity so that the right elements can be applied to technology projects? Dr. Elia, would you like to take this question? Maybe on cybersecurity and AI? Any recommendation?
I will do my best.
We will jump in as well, do not worry.
So basically speaking, I don't think that you really need a certification here. I think what Donata said was extremely helpful for the audience. So I would probably combine, if you are willing to study AI for cybersecurity, I'd probably just combine different certifications or perhaps degrees in cybersecurity specifically, and then in AI, because I'm currently unaware, and please let me know if I'm missing something. I'm currently unaware of any specific degrees or certifications that would focus exclusively on AI for cybersecurity. Maybe we have some online courses that offer, some content specifically dedicated to cyber and AI, but honestly, two disciplines are fairly different. So I would consider studying separately cybersecurity and AI.
Yeah.
If I can add one or two lines, there are a website called Kaggle where you can participate in.
Yes.
If you wanted to learn AI, you can. There's a website called Kaggle where you can, do the play around and do all those stuff. And also you can install Jupyter notebooks
Yes.
on your machine and play around with that. And regarding a course and certification, there is a postgraduate program in AI in UT Austin, University of Texas at Austin. It is entirely Austin, and UT Austin is a well recognized public university in the US. So you may try that one as well. There are a ton of other certificate courses, and if you wanted to look for as a postgraduate certificate, UT Austin has AI course. I think that is there for like a year time or something, but that is worth trying as well.
If I
Yeah,
can
sure.
add,
Oh, sorry, go on.
if I can add something real quick too, not cybersecurity, but the International Association of Privacy Professionals has a course and a certification for the Artificial Intelligence Governance Professional, which discusses AI, discusses issues with AI governance, as well as legal and regulatory frameworks and the AI principles as well. Nadia, is it okay if I add a link to that in the chat?
Of course, please do. Coming back on the certification, so the British Computer Society has an AI ethics certification that was done with the City of London, so that you can join that. There are, as was mentioned by Sanjan Khan, there are many universities. I actually worked on one with the University of London, which is they have a BSc and a master in data science and AI. Now, coming back to the security certification, Dr. Elia, would you have any references? So on the key certification in cybersecurity that could probably Gurpreet could look at?
Talking about
Because
cyber.
there's ISAC, obviously.
Sure, in Osaka, we have IC Square, we have SANS Institute. So I would say it really depends on what you are trying to achieve. If you are looking to expand your knowledge in governance and strategic management, I think ISACA and IC Square will probably be the best. Then if you are looking for technical skills, probably I would say SANS Institute will work the best. But you also have offensive security. They have, I would say, fairly advanced and purely technical certifications. So it really depends on your goals and objectives.
Yeah, thank you so much. So Gurpreet as well, on Python, you have the Python community, you have different courses. I will definitely recommend you to have a look at that. So with this, I think you'll find your happiness. We have another question related to quantum computing. Which industry could quantum computing technology be a game changer? How can it impact the society like information technology did? Anyone would like to pick up this question?
Yeah, sure. Thank you. So, quantum computing is not only meant for a specific industry, as you know, right? Many people, most of us, when I was doing my PhD in quantum computing, I was having the same thought. I mean, can we replace quantum computer with a classic computer? No. Classic computer has a different purpose, whereas quantum computer has a different activity, right? So we'll be having the same things, but I mean, if you guys have gone through recently, we have developed quantum teleportation. It means we can connect with any device and we can have the quantum internet. I'm doing research in the quantum internet right now. So quantum computing is meant for every industry. For example, in supply chain issue, we have used in Amazon warehouse. We are also using in healthcare. We are also using governance program in United States, and also we are using the quantum cryptography and also quantum cybersecurity, which is very essential, like quantum AI or quantum machine learning and quantum deep learning tool can be utilized. And then major application of quantum computing is like manufacturing. Typically in my current industry, Amplify, we are using quantum computers for battery cell, electric vehicle battery cell for heavy trucks. So we are a company, Mercedes Benz. So I mean, we can use quantum computer everywhere. But remember, quantum computers are not going to replace our classic computers. So our classic computer, whatever we have, we'll be using that, and quantum computer would be a add-on to multiple like problem solver, I would say.
Okay, thank you so much. Yes, I heard someone wanted to speak. Says, who was it? I can't see. Anyone else wanted to add something? No. Okay, so if that's the case, then I will move to our last slide, which is if you are interested in BCS. So obviously, BCS is the British Computer Society, as mentioned. It's organizing different interest groups. There is in quantum, there is in AI, there is in cybersecurity as well. Darren, would you like, because you've worked fantastically to set up this first webinar for the US members, and I think it's just right, for you to say a few words. What motivated you, or what's your vision, and how are we taking it from there?
Thank you, Nadia. I really appreciate that, and thank you everybody for taking the time. My vision for this really was that we've got a growing US community who are trying to find ways to get involved with BCS. And specifically with our US community, there's a very heavy AI bias within their learning and work environment. So this initial first session, based predominantly for our US community, was trying to bring some experts together and just from a high level showcase some of the people that we've got in our community, see what resonates, and ideally make this a more regular thing. So I would hope that this is a first one for our US community, that we would start making these a more regular thing. I'd also like to kind of bring our US community, who are, as I said, predominantly based in AI, closer to some of our UK and European groups, which, as Nadia spoke about, we have a lot of people who are in cyber, AI, and in quantum. And that's quite a heavy part of our membership basis. And it's a very kind of growing sector of our community that I think one of the points earlier on that was mentioned, that actually whether you're in AI, you're going to have to understand it or be involved in it in some point. So I think, having some experts kind of bringing it forward, sharing their stories, for me, it's been absolutely fantastic. If there are any stories or any of our presentations you've heard tonight that you would like to hear more on, yes, I'd love to bring some of our guests on and do a longer presentation. I appreciate 12 minutes was probably not enough for any of them, but I really wanted to just show a breadth of some of the capabilities and the people that we've got. If you are not a member of BCS, by all means reach out on that link and have a look. If you are a member of BCS, we do have a very wide group of special groups you can get involved in. So have a look on our events page, have a look at some of the different groups on there. Please do reach out, and you will find likes of the people that you have heard from this evening who would be happy to welcome you into their conversation or share some more expertise, or actually, you know, help support with some of their wider stuff that they're involved in. So I just want to say thank you very much, you know, for everybody being involved in this, and thank you very much, Nadia, for guiding this through. Hopefully, you know, this is the beginning of more of these sessions to come. So thank you very much, everybody, for taking the time out on a very busy weekend. And if you're in the UK, this is a bank holiday weekend, so appreciate that our attendance and signups may not have married, but we had 160 people who signed up for the webinar, so there'll be 160 people receiving this recording afterwards, and I'm sure there'll be a lot of consumed articles and content from this, and probably a lot of questions that come back, which I'm sure I'll be relaying to our community if I obviously can't answer them. So thank you very much. Back to you, Nadia.
Thank you, Darren. So as you said, there is a big interest in the AI community. So once you join, so I'm part of the specialist groups, and I'm going to cover a couple of the points that we're doing for the moment. So I'm delighted to see so many of you interested in our science. So when you join the BCS, you can select your specialist group that you're interested. Please do that, because we have a very busy events list that we organize all the year round. So once you click, then you are part of our members, and then you will receive all of the agenda. So we organize on a regular basis online webinars on different topics within the AI field. We have every year a big conference in Cambridge where we actually have a technical paper and obviously a technical paper and an industry paper. So please look at, if once you join and you want to submit your papers, which are academic papers, then you can do that and you will be informed. And then after, obviously, there's different committees for the selection. Other elements that we organize as well. So I used to run a machine competition. I revamped it, so it's in progress. So John and myself are working on the return of the competition, and it's basically a platform to showcase what you have done and to showcase to the whole AI community. So there's a lot of interest in that as well. So please keep an eye. Hence, that's why once you join, please select AI specialist group, and you will be in our distribution list, and you'll receive all of the information. I'm on LinkedIn. Feel free to connect with me if you want, if you have any question as well. And as Darren mentioned, Darren, John, and myself, we're delighted to have an amazing community in the US and in Americas, and we will be working to make sure that you have you have some events that will help you in your career development as well. I think that's it for me, unless John, you as a head of community, if you would like to add something.
Very, very kind of you, Nadia. Just, you know, just second thank you to all of our speakers this evening and everyone for joining. Really appreciate that the weekend is approaching, so I'll allow you to sort of move on with your days. Thank you very much for joining.